Okay, AP Statistics. We're doing lesson 5.2 today, probability rules. Let's get into it. So we're going to look at probability models. Modeling is what we use to represent situations and circumstances, okay? So each probability model consists of a sample space, which is the entirety of all possible outcomes. So in this sample space, we're rolling, well, writing in white on white is not going to really help, is it? We're rolling two die. Die? Whatever. So, like, that's both die being rolled, and they both got a 1 as an example. Okay, erase it. What's happening here? All right, sorry. Okay, so this is the entire sample space. This is every possible outcome for rolling two die. The probability is the chance that each outcome will occur. So what's the chance that just I roll a 1 on one die and a 1 on the other die at the same time? That's an event. The event of that is rolling a 2, right? So let's look at our example here below. The sample is rolling two die. That's the entire sample space. We just talked about that. The event is they add up to 5. So what we're really looking for is when does this happen? That's the event. So if we look here, 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. And that is it. I'm not going to get 5 any other way. So I have 4 ways, right? This is the event, 4 ways to get the event. And then how many are there? There's 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. 6 times 6 outcomes, that's 36. So the probability of the event of two die adding up to 5 is 1/9, which if in a decimal, that's 0.1, one repeating. So now we have some notation and some terminology. The complement, okay, this is an important word, of an event is the probability that the event does not occur. So if PE, just a random example, symbolizes the probability of some event E, then P of E with a C, which I don't like that notation, by the way. It's not how I learned it. Okay, symbolizes the complement of an event. A complement can be found. So another way to write this would be P of E and like a little apostrophe up here means P naught. P of E naught equals 1 minus P of E. So the P of the complement of E, probability of the complement of E is 1. So this is the total sample space. So in our dice example, that's all 36 possible outcomes minus the probability of our sum. So let's look at that. So using two dice, what's the probability of the sum not 5? So if P of E equals sum is 5, P of E naught is the sum not 5. So we have, I'm going to move back over here to the left. 1 is the entire sample space. We found that it was minus 1/9 was the probability of the sum being 5. That's going to be 8/9, right? So that equals P of E naught in this case, the complement of E, okay? Looking at exclusivity, so two events are mutually exclusive if they cannot happen at the same time. So the probability, for example, if probability of rolling two even numbers and those two even numbers adding up to 5, that's impossible. You can't do that. So these events are mutually exclusive. They cannot happen at the same time. Okay. Two events are inclusive if they can happen at the same time. So at least one number is 2 and the sum is even. That's possible because you can roll a 2 and another 2. That sum is even. You can roll a 2 and a 4. That's even. You can roll a 2 and a 6. That is even, right? There are events that don't occur in here, but these two things are inclusive. They can both happen at the same time. So now we have some rules. These are rules that govern probability. These things must be true. All probability is between 0 and 1. We talked about that before, okay? All possible outcomes together must have a probability whose sum is 1. The total must always be 1. If the total is more or less than 1, then it's violating a rule of probability. If all outcomes are equally likely, probability of an event can be found. We did this with the dice example. So here's event A. It's the number of outcomes that correspond to event A, so rolling a total of 5 with 2 die. That would go in the numerator. In the denominator, you get the total outcomes of just all possible outcomes of a die being rolled. Okay, it looks like the notes cut off here. So if events are mutually exclusive, then the probability of A or B, meaning A and B cannot happen at the same time, it's going to be the probability of event A plus the probability of event B. So that would be rolling 2 even numbers or the sum being 5. Right? These can't happen at the same time. One that's missing is, I'll write it in. So if events are inclusive, meaning they can happen at the same time, okay, there's overlap, then the probability of A or B, so rolling at least one number being a 2 or having a sum that's even, is going to be the probability of A plus the probability of B, and then you subtract where they overlap. So from our previous example, that'd be when you have a 2 plus a 4, right? So hold on. Let me back up. Why can't this thing erase? Okay, so the reason you have to subtract that is because you'll be counting some of these twice, and that would give you an improper solution. Also, a little more on notation here. The word or is written as a U. The word and is written as an upside down U. Looks like a big N. So P, let's do it up here. This notation here would be P of A or B, also known as union symbol. This here would be the same thing, but you notice that we have a different equation. So this gets written as P of A intersecting with B, okay? All right. So let's look at an example that answers some of these questions. Here, we're randomly selecting a student that took an AP exam from 2010. And here's the probabilities. This is the breakdown of all the scores. This is the proportion that scored a 1, a 2, a 3, a 4, and so on. So if we randomly select a student, we're saying what's the probability that that student will fall in one of these categories. So we want to show that this is a legitimate probability model. So that's the question. Are all the numbers between 0 and 1? So far, so good? Yes. And if I add these numbers together, do they add up to 1? And they do. Oops. They do. They actually add up to 0.99. This is close enough to 1 that we can account for. There's probably some rounding that occurred in here. That would give us slightly off, but this is good. This just means that we rounded. Next, we want to find the probability that we grab a random student and they scored a 3 or a 4 or a 5. So what does that look like? So first we write the probability of our event, 3 or better. And then we are adding the probability that they scored a 3, plus the probability they scored a 4, plus the probability they scored a 5. If you notice, we're using this top formula here because these events are mutually exclusive. A student taking an AP exam cannot score a 3 and a 4 simultaneously. They get a 3 or a 4, but not both. They're mutually exclusive. So we add these 3 probabilities and we get 0.584. That's our probability that we randomly select a student and they got a 3 or a better.